All right, let me get another one here. Okay, now when you're evaluating trig functions of any sort of angle, the first thing you want to do is you want to determine your reference angle, theta prime. And then the second thing you want to do is you want to, depending on which quadrant theta lies in, you want to fix the appropriate sign to the function value. Okay, so let me write those steps up here. So evaluating trig functions of any angle, right? So this is not just for acute angles like last section. So number one, determine the reference angle if it's outside quadrant one. Reference angle theta prime. Number two, the second thing you want to do is depending on the quadrant in which theta lies. You're okay, you can vacuum. Yeah, it's fine. Number two, depending on the quadrant in which theta lies, you fix the appropriate sign to the function value. So fix appropriate sign, okay? Depending on the quadrant. Sorry, they're vacuuming my classroom, but I think you'll be okay still to hear. Okay. So here's an example. Let's do sine 5 pi thirds, okay? You're like, well, let's see, 5 pi thirds, how much is that? Oh, it's about what, 300 degrees or so? So you want to make this visual. So I rotate. All right, like I got to rotate these 300 degrees, right? Looks like I'm into quadrant 4 here. Sine of 5 pi thirds. So theta is 5 pi thirds, or 300 degrees, right? Or 300 degrees. So the question then becomes, well, what's theta prime? What's theta prime? How much more do I need to go to make it all the way around to 360 degrees? Well, 60 degrees, right? 60 degrees. So now what you want to do is you're going to make this into a right triangle trig kind of a problem here. So I'm going to draw it straight back, okay, and I'm going to make a 90-degree angle. So I got this right triangle trig, and I notice, hey, I got a 30, 60, 90 triangle, okay? So opposite the 30 is 1, hypotenuse 2, root 3 the other side opposite that 60 degrees, okay? Now, when I say a fixed appropriate sign, I mean, you kind of got to jimmy rig this because you see how you go in the positive direction, okay? So the 1 is positive, but then we go into the negative direction, which is, you know, your y value is going to be negative. So I'm actually going to make this a negative root 3 so that this works out for me, okay? And then leave the hypotenuse positive always, okay? So because what happens here is you know that the sign is opposite over hypotenuse, correct? Or negative opposite that 60 degree, negative root 3 over 2, opposite over our hypotenuse over 2, okay? Now, why did I have to fix the appropriate sign? Why did I have to name that negative root 3? Because if this happened to be the unit circle, and you have this x comma y, you remember how with unit circle trig, your y value is your sign value right there? Well, your y value is negative, right? Your y value is negative. So I got to name that negative root 3 so it ends up being that the sine of 5 pi thirds is negative root 3 over 2. So it ends up being a negative number there, okay? Because I'm in quadrant 4, okay? So if you think about all the quadrants, okay? In your quadrant 1, your x value, your cosine value is positive. Your sine value is positive, right? Of course, your tangent value, your sine over cosine, is also going to be positive. Whereas in quadrant 2, your x value, your cosine, is now negative. Your sine, your y value, is still positive. But your tangent, your sine over cosine, you know, you're going to have a positive over a negative is a negative. Quadrant 3, you got your cosine, that's negative. You got your sine, that's negative. Negative over a negative, sine over cosine is a positive. Quadrant 4, okay, your cosine, whoops, oh, that drives me nuts. Your cosine, your x value here is positive. Your sine, your y value is negative. Your tangent is going to be negative. Sine over cosine, negative over positive. Okay, so we got to kind of, again, we got to jimmy rig it because this right triangle trig definitions only pertain to acute angles. And now we're trying to expand it outside of acute angles. So we're going to use these reference angles, these theta primes, to set them up and to do it that way. Okay. So let's do another one. Let's say we have let's see, how about cosine negative 60 degrees? Cosine negative 60 degrees. Okay. So I've rotated negative 60 degrees, right? I've rotated negative 60 degrees. And what's my reference angle? Well, guess what? Theta prime is 60 degrees, right? Theta prime is the distance, again, between the terminal side and the horizontal axis. Now I create a right triangle. I say 60, that's a 60, 30, 60, 90 again. 1, 2, root 3. 1, 2, root 3. Oh, this wasn't the greatest problem. Looks like it's the exact same problem, isn't it? Oops, sorry about that. Let's say, you know, let me change this. Let me go like this. How about cosine negative 45 degrees? Okay, let's rotate negative 45 degrees. Okay, so I rotate negative 45 degrees. So my reference angle, my theta prime, is actually 45 degrees in there, right? How much is this theta prime? 45 degrees. I draw that right triangle. I say, oh, this is a 45, 45, 90. 1, 1, root 2. Positive x, negative y. So I got to make this a negative 1 right there. Positive x, negative y. In other words, my cosine is positive, my sine is negative. Okay, so the cosine negative 45 degrees. Cosine is adjacent over hypotenuse. 1 over root 2. And of course, I'd rationalize that. So the cosine negative 45 degrees is root 2 over 2. Okay, it's a good place to stop.